In this video, we're going to be looking at multiplying rational expressions. So to multiply rational expressions, we can think of it as multiplying fractions. So remember, when we're multiplying fractions, we just multiply across. We multiply the numerators, we multiply the denominators, and then we write it in simplest form. So let's look at some examples. So for this first one, I have this 8x cubed y over 2xy squared times 7x to the fourth y cubed over 4y. So I'm going to go ahead and first just multiply across. So 8 times 7, I get 56. X cubed times x to the fourth. Remember, we add those exponents. So I get x to the 3 plus 4, which is 7. And then y times y cubed. Remember that y really has an exponent of 1, so this would become y to the fourth. Over 2 times 4, I get 8. X, and then y squared times y, I get y cubed. And so now we can kind of think of this as simplifying three different parts. So I can separate this out to be, okay, I want to simplify 56 over 8, x to the 7th over x, and y to the 4th over y. Well, 56 divided by 8, I get 7. X to the 7th divided by x, I get x to the 6th, because 7 minus 1, I get 6. And then y to the 4th divided by y, I subtract those exponents, and I get y cubed. And then I need to state any restrictions. Well, I see in the very beginning that I have x and y in the denominator, so that means that x cannot equal 0, and y cannot equal 0. Okay, let's look at this next one. So here I have 3x minus 3x squared over x squared plus 4x plus 5 times x squared plus x minus 20 over 3x. So I recommend, before you go ahead and multiply, because you're going to multiply across, that's going to be a lot of work, I would recommend going ahead and factoring first. So when I factor the top for this left hand, I see with 3x minus 3x squared, they share a 3x. However, I always like having x at the beginning of the expression because that's how it normally looks whenever we factor. So I want to take out a negative 3x. When I take out a negative 3x, this becomes x minus 1. And then when I factor the bottom, I have x minus 1 times x plus 5. Because this really should have said minus 5 here, which I'll have that corrected for you on your notes. Times x squared plus x minus 20. I want to factor that, so I'm looking for two numbers that multiply negative 20 but add to 1, and that's going to be x plus 5 and x minus 4 over 3x. And then now I'm going to go ahead and multiply across. So when I multiply across, I basically just have negative 3x times x minus 1 times x plus 5 times x minus 4 over 3x times x minus 1 times x plus 5. And so now I'm looking for common factors on top and bottom. Well, I see I have a 3x on top and bottom. But remember, this negative is still up here. So I still have a negative 1 up on top. But the 3x's cancel. I have x minus 1 that's in common and x plus 5. And so that means all that's left is this negative x minus 4 on top. And if I go ahead and distribute that negative, that means that this becomes negative x plus 4. Then I want to look for restrictions. So for my restrictions, I'm looking at what values of x make my denominator equal 0 on both fractions. So for this first fraction, I see for x minus 1 that x can't equal 1. For x plus 5, x can't equal negative 5. And then for 3x, x can't equal 0. let's look at this next one. So here I have 2x minus 8 over x squared minus 16 times this other fraction. So I first want to factor everything. So 2x minus 8, I see I have a GCF of 2, so I can factor out the 2. And I get x minus 4 that's left. Factoring x squared minus 16, I see that's a difference of squares. So this is going to be x plus 4 times x minus 4. Factoring x squared plus 5x plus 4, I get x plus 4 times x plus 1. And then factoring x squared plus 8x plus 16, I get x plus 4, x plus 4. And then now I can go ahead and multiply across. So when I multiply across, I have 2 times x minus 4, x plus 4, x plus 1, over x plus 4, x minus 4, x plus 4, x plus 4. So a lot of x plus 4s. And so now I'm looking for common factors in top and bottom. Well, I see I have an x minus 4 on top and bottom that I can cancel out. And I have one x plus 4 on top and bottom that I can cancel out. And so I see that leaves me with 2 times x plus 1 on top. Over on the bottom, I'm left with 2 x plus 4s. And I see that this is now completely simplified. Then I need to state any restrictions, and so I see for the denominators that x can't equal 4 and negative 4. Because that would make my denominator 0 if I plug those in. Okay, now let's look at one last one. So here I have x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. So now I don't have a fraction on the right-hand side. That's okay, I can really think of this as being over 1. So when I rewrite this, I want to factor everything. So x plus 2, that can't be factored. X cubed minus 27, I see that this is a difference of cubes. And so I'm going to go ahead and just rewrite this. So I can think of this as x cubed minus 3 cubed. And when we factor that, remember our analogy of SOAP. So same, opposite, always positive. And so that was my signs that are going to be in there. So I have negative, opposite, positive, always positive. My A here is x, and my B here is 3, so I have x and 3 here. This first term here is going to be a squared, so it's going to be x squared. My last term is b squared, so it's going to be 3 squared, which is 9. And then the middle term is a times b, and so that is 3x. Again, if you need review on factoring, please go and review those factoring videos in an earlier unit. And then times x squared plus 3x plus 9 over 1. Multiply across, and I have x plus 2 times x squared plus 3x plus 9 over x minus 3 times x squared plus 3x plus 9. And so looking for common factors, I see that I have that x squared plus 3x plus 9 that's in common. And so that means that my answer here is going to be x plus 2 over x minus 3.